Good morning. I'm Jeon Shin. I'm Associate Administrator for Aeronautics at NASA. And I welcome all of you in the room and also on the net for today's Aeronautics Technical Seminar, Aviation and Environment, Managing the Change of Growth. We are seeing more and more the environmental concerns are shaping the aviation growth. And in order to enable this growth that we're anticipating, it is vital to address this environmental challenge. And it is my pleasure this morning to welcome Mr. Carl Grossen. He's the Director of FAA's Office of Environment and Energy, and very important office that develops national aviation policy and standards relating to aviation, environment, and energy matters. He also serves as the director of the Environmental Working Group for the Next Generation Air Transportation System. As we all know, that is one of the several working group in Jpdo. Mr. Grossen has held a number of important posts within FAA, long, rich career that he has had to date. Prior to coming to this current position in 2001, he served as the Chief of Staff to the FAA's administrator. In that capacity, he coordinated aviation policy activities and advising administrator on major agency initiatives, including negotiations and briefings with Congress, industry, special interest groups, other federal agencies, and state and local officials. In 1990s, Mr. Morrison was the FAA's Senior Liaison with governments, civil aviation authorities, and aviation industry in Northern Europe. That's kind of a job that we all want to do, right? Very fruitful and productive career that he had in that area. And working out of the U.S. Embassy in London, he oversaw and coordinated FAA activities with many European countries, including Denmark, Finland, Iceland, Ireland, the Netherlands, Norway, Sweden, and the United Kingdom. He also worked extensively on FAA liaison activities with the European Joint Aviation Authorities. That's their equivalent of FAA in Europe, which is a group of 27 European civil aviation authorities. Prior to his appointment in London, Carl managed the International Operations Branch of the FAA Office of International Aviation at FAA headquarters. He has earned graduate degrees in international development from American University and economics from Boston University. He also holds an undergraduate degree from University of Virginia. So with that introduction, Carl, thank you very much for being here. And let me introduce Carl Grossen.
Thank you very much for that kind introduction. And as you heard in my resume, I actually had the pleasure of serving in London, and there was always a discussion between myself and the FAA rep in Paris of who had the better job. And I think my view was that I at least talked somewhat of the same language of where I resided. But Tony Fazio, who resided in Paris, said, yeah, but Paris has better food. So again, it's really a pleasure to be here and to talk about what I see as really probably the central challenge for aviation growth going forward. I think as I'll try to explain in going through this talk, the environment probably is going to be the challenge that is most going to constrain growth. It's, despite what you see in the headlines and safety today, I don't think it's going to be safety. Security is always an issue from time to time, but when you really look at the long-term trends and the things that I think are really going to challenge us, I think it's going to be about environment. And again, I think, as I want to try to share with you this morning, not just what FAA is doing, but a lot of what is going on in NextGen and our plans to move forward. So, next slide, please. So as you can see the chart here, what I want to touch briefly on is the historical record, where we've been in terms of environmental challenges, what we see as some of the evolving challenges that we're going to have to tackle, how we propose to move forward in the NextGen plan, some FAA proposals before Congress, which I think are going to help us, and to also pose this question, can we succeed? Because again, I think that's an important issue, and certainly here having the privilege to talk to NASA, I think you all are an absolutely essential part of whether we actually are going to be able to succeed, and then just offer some closing observations. So next slide. I always like to start with this slide when I'm talking to audiences about aviation environment, because most people think environmental challenges are new. And I like to point out, and certainly this crowd knows about the Wright brothers, but what you probably don't know was that the first editorial against aircraft noise was published in 1911 in Aero magazine, and it was titled "On the Fitting of Silencers." And basically it said, to quote, that the tremendous racket that is present associated with the airplane plays a considerable part in prejudicing the public against these machines. So I think the good news for all of us in this industry is that we've been able to deal with enough of the noise to reduce the prejudice so that we now have more people, about over 2.2 billion passengers flying internationally, globally in the aviation system. And so that's larger than the entire population of the world in 1911. So clearly, I think on that basis, we've had some tremendous success. Next slide. And I think looking forward, aviation clearly has come to become a absolutely essential part of the global economy. You can see the numbers here in this chart. 8% of global activity, 40% of value of freight. For the United States, you're talking about 10 million jobs, about 5.5% of GDP. And you can see just going forward, it's an essential part of how the world looks at developing countries. And certainly, you can see that last bullet about anticipating 9 billion passengers by 2025. Really quite extraordinary growth in the past, and certainly forecasts going forward. Next slide. So how do we get there, and how do we get this great record on noise? So let me just walk you through a few charts. Basically, in the United States, we look at significant noise as by a measure called DNL, in essence, the amount of noise over a 24-hour period, a decibel level, 65 decibels. And you can see in this chart, basically, you can look at either 55 or 65. And in any case, however you look at this chart, it's really been quite successful. You can see we've had about a 93% reduction in significant noise levels, or population exposed to significant noise levels in the United States. Really quite extraordinary. If you go to the next chart. And again, how do we get there? Well, this chart conveys it pretty well. This huge improvement in technology in the aircraft. 20 decibels is really quite extraordinary, as I'm sure you folks know, in terms of a reduction in perceived noise in the human ear. And we've had it over this last 35 years, and it's produced that kind of reduced noise exposure in the United States. And I think what's critical is not only did it produce noise exposure reduction, the nice thing about the technology and why it got so widely adopted, it was actually cost savings too. What people often forget is the reason the airlines were so aggressive in buying that new technology is because it actually saved fuel too. Next slide. So here's, again, just to give you a sense of kind of the growth we had in that time period. So you can see the population exposed in the blue. Again, about a 93% improvement. And at that same time, we had about a 2.5% increase in the number of passengers in the United States system. Again, in most cases, people would say, wow, pretty good success in this area. So hold that thought. Next chart. So at the same time, that we've had this incredible noise improvement, we've also had very significant improvements in terms of emissions performance. You can see in the top left-hand chart, we put together this energy intensity chart of looking at automobiles versus aircraft. And it's pretty extraordinary when you think that today's aircraft on an energy efficiency basis is actually more efficient than today's auto in the United States. We've actually have some other charts which basically show that from about 1985, 20 years forward, it's not just autos, but any other form of transport in the United States, aviation has done better in terms of improving its energy efficiency. So quite an extraordinary record. And you can see in the other chart, again, not just in terms of overall energy efficiency, but you can also see improvement in all the criteria pollutants, all the things that are regulated by the EPA and ourselves in terms of trying to reduce pollution. Again, a really good story. Again, with probably the exception, you can see that one red line. NOx has not been as good in terms of reducing that, but again, not a surprise given the nature of combustion that has given us the fuel efficiency improvement as well as the noise improvement. Next chart. So again, this is where it's gotten us in terms of emissions. On the left-hand side, you can see the greenhouse gas emissions. Aviation is a very small part of overall emissions in the United States. And on the NOx, again, you can see, 0.5%, an extraordinarily small portion of NOx sources in the U.S. Now that said, again, a different way of measuring it, not just on a national level, is a local level. And clearly here's where we have more of an issue, because an airport with all the aircraft flying in there can, depending on the particular region, might be 5, 6, 7% of a region's contribution for NOx. So then it can become a very significant problem. Next slide. And then finally, just to give you some recent trends, the FAA actually started measuring energy efficiency a few years ago. In fact, I think we were the first civil aviation authority in the world that actually looked at this as a system metric as important to measure in terms of performance for the system. And the blue line is what we set as our goal, which was usually about a 1% improvement. And you can see in the pink line that we far exceeded that over the last few years. And on the right-hand side, this is a chart basically showing the overall commercial fuel consumption in the United States. Large drop after 9/11, but again, still about 4% below the amount of fuel we were using in 2000. And again, I think it's important to note that even with this less fuel consumption, the system in 2006 moved about 12% more passengers and about 22% more freight. So again, a really good record in terms of aviation's performance in both these areas. Next chart. So in 2000, basically, this is where we were with all these tremendously good gains in technology, a very large reduction in emissions footprint, a very large reduction in noise footprint. The GAO went out to the top 50 airports in the United States and said, clearly FAA's done all this great stuff, NASA's done all this great stuff, industry's produced all this great stuff, so clearly there are no environmental issues in terms of capacity expansion. And of course the answer was no. They surveyed the airport operators in the United States and found out there were significant issues in terms of noise, water quality, and emissions. And you can see in this chart, noise was rated as the top issue then in 2000 and forecast to be the most important issue going forward. Water was number 2, but you can see air quality was the one that was going to be coming up as important. And I think, so this is basically the situation, at least I found myself when I took this job in 2001, that despite all the tremendous progress in the past, there were still significant challenges, and trying to get an airport built, trying to get a runway added, trying to expand operations still was becoming a very difficult issue despite all the progress. Next one. So let me talk a little bit about what has happened in the last few years in terms of evolving challenges. Next slide. So first, the GAO was right. Noise has not gone away as an issue. You can see in this chart basically just the continuing upward trend in all these different kinds of noise measures that in some way, shape, or form restrict the ability of aircraft to operate at particular airports. I think it's important to note how noise, I think, still in the United States is the #1 issue. Just to give you a sense, I spent 2 weeks at ICAO at the assembly. This is the UN organization that basically sets standards in both safety, security, as well as environment. And when I was up there in September, the discussion, almost all the discussion at the ICAO assembly was on emissions and climate change. And when I came back to Washington, I got a call from Congress saying, we'd like you to come up and testify. I said, I'll be glad to tell you what happened there. And they said, no, Mr. Burleson, we want to hear about aircraft noise. So again, I think it's important to remember that despite all the other issues, and clearly there are some significant issues in these other environmental areas, noise tends to remain a central issue of aircraft and aviation expansion. Even in Europe, where again there's a much larger interest and concern about aviation's contribution to climate, when you have the A380 having to make a design choice between noise or fuel burn, there's actually a willingness to make a design change for a fuel burn penalty of about 1.5% in order that it can meet the noise requirements of Heathrow. So again, these are hard issues and to tackle everywhere in the world. Next slide. And again, in the United States, I mean, the good news, clearly, one of the silver linings, if you would, out of the fleet restructuring after 9/11 and the fuel prices has been we've had about a 70% retirement of hush-kitted aircraft in the United States in the last 6 years. So that has helped contribute greatly to this large decline in terms of noise exposure. But as you can see, the challenging part is on the dotted line that, one, we've revised our goal, because we took a look. We had originally set a noise goal of about a 1% improvement per year. We went back and looked historically what was going on in terms of trends in the United States and said it's probably a fairer goal to put it at about 4%. So we've increased our own requirement of where we want to get, but you can also see in our forecasted trend that noise over time is going to go up. So at some point in the future, those lines are going to cross. Where that exactly is going to be is a little uncertain, again, given all the fleet restructuring. But again, I think that does say that we have a challenge going forward in noise. Next slide. Now what you can see here, and again, this shouldn't shock anyone, is we have this other challenge on air quality. Airports, not surprisingly, tend to be located in urban areas. Urban areas, not surprisingly, tend to have more of the air quality problems we have in the United States. And so you can see in this chart, in terms of our 50 largest airports, that a large percentage of them are either in ozone non-attainment or particulate matter non-attainment areas. So what that translates into is every time a capacity expansion project wants to occur at one of our key airports, which moves about 93% of our traffic, we run into problems of local authorities being concerned about how that's going to contribute or impact air quality and the need to take additional measures to reduce that. So over time, it tends to create more political opposition to actually expanding capacity. So again, another challenge going forward. Next slide. Another issue that we've certainly has been highlighted in the last couple of years is aviation's continued reliance on kerosene. There was a National Academy study done a few years ago that basically forecast that aviation would probably be the last mode that continued to use kerosene, and this becomes an issue because I mean, I will confess, I'm trained as an economist. And as I've shared with some people, I have no idea whether, peak oil is happening because, again, I was once told the reason economic forecasters were invented was to make astrologers look good. But I think what we clearly see in the marketplace is a structural change in the demand for the reserves that we do have with the huge growth in India, the huge growth in China. So there does seem to be a rebalancing of demand and supply in the world, which is clearly translated into significant oil price increases. Next slide. And I think this has produced what is really a structural change in U.S. airline operations. I mean, this is a pretty extraordinary chart when you look at it. The blue line basically is labor cost over the last 35 years, and the red line is fuel cost. And you can see that over this long history, fuel has never exceeded labor costs for U.S. airlines until the last couple of years. Fuel costs today, depending on the airline, is somewhere between 27 and almost 40% of some airlines' fuel cost. It's really become an extraordinary factor in influencing operations. I mean, no one would ever accuse airlines of having great food to begin with, but now they literally ration the number of bags of peanuts that they are putting on planes. They've pulled cell phones out. I mean, anything possible to reduce weight, because it all translates into fuel burn and cost. We've seen headlines in the last couple of weeks bringing this home again, where we've had 3 airlines go bankrupt. Doesn't sound like a lot, but that was actually within a space of about 10 days. We just took out 1% of the U.S. capacity because of fuel prices. So again, there's extraordinary things going on. I mean, when you think of the fact that ATA, which represents about 95% of U.S. airlines, tell me that in 2000, their airlines paid about $16 billion for fuel. So buying $250 million or $250 million gallons less in 2006, they paid $41 billion. So really quite an extraordinary change in the cost structure. And I think this really has driven at least part of what we need to do in NextGen in terms of long-term strategy to deal with this fuel cost issue. So next slide. Another large issue that has really influenced the debate has become this whole set of treaty developments and increasing attention on climate change internationally. I've just included a couple of the key international treaties, United Nations Framework Convention, again, which almost every government in the world, including the United States, has signed up to. And as you can see here, that treaty commitment says there's a general commitment to reduce greenhouse gas emissions. The Kyoto Protocol, pretty famous for the fact that the United States is, I guess, now the only country that hasn't signed up to it. Again, as it came into effect in 2005. But again, for aviation, what was important about Kyoto was the fact that it recognized that in the case of aviation and shipping, these were two very different industries than most others because of their global nature. And so basically, they asked these two UN organizations to try to tackle greenhouse gas emissions from these industries. And you can see in the last set of bullets, ICAO has been working on this over the last few years. In 2004, adopted a set of environmental goals, including limiting and reducing greenhouse gas emissions. At the last assembly, we approved emissions trading guidance. I have to say, based on mutual consent, and we'll talk a little bit about that in a second, but there was dissent from Europe because Europe has a slightly different view on how to move forward on emissions trading. And then also importantly, ICAO created this high-level group on international aviation and climate change, which my boss, Dan Elwell, represents the U.S., and there's 14 other countries. And again, this is a very high-level political group that's been charged now that hopefully within the next couple of years of coming up with a plan of action that all the world can agree on and try to bridge the differences we had at the Assembly. So next slide. I'd like to share this, what I call the mania slide. And again, what's important to note in these quotes, what I don't want to convey is that climate change isn't important. It absolutely is. The U.S., certainly in the aviation world, is absolutely committed to trying to address it. But what I do want to convey is it's been amazing to watch the change of how the aviation sector has completely lost credibility in Europe. Again, I was the FAA rep in London. I was there till mid-99. And it's amazing, when I left there, there was really nothing in the newspapers about aviation and climate change. It was mostly about noise. And it's extraordinary to me in what a short period of time that aviation has sort of become public enemy number one. You can see in these quotes, that last quote is, I think is pretty extraordinary. Basically, someone advocating murder in the public press and no one, thinking much of it. It really is an interesting process, and certainly my boss and I were in Brussels probably about, let's say it was about 3 weeks ago. And again, it's really amazing in trying to talk about aviation and climate change. As we were trying to talk about performance-based goals and measures, it's clear that in the political process in Europe, they are very constrained. It's gone beyond a performance debate, and in essence, something must be done on a mandatory regulatory basis. There's almost a sense that somehow aviation, there must be some punitive measure in order to satisfy the political process. So it's really quite an extraordinary debate. And what I like to share this with folks here is as a warning. I mean, again, given how quickly it changed in Europe, we should not, we should take a warning and not be complacent that the same kind of debate might start here. Again, I think it would unfold differently, but it is a warning, and I think importantly why we need to really find good technical ways to address aviation and climate. Next slide. So the next challenge we face is this demand profile. And I think, again, I'm not going to get into a lot on this chart, but the real issue here, as you can see, is demand, however, multiple forecasts for demand in the United States market, and they're all going up. But the other thing is how that demand is going to be met could be very different. Depending on what your belief is, it could be met by A380 larger aircraft. Another operation at O'Hare won't have a lot of incremental impact. Or we might have a spread of very small jets at 500 new airports that have never had jet service before, which could be a fundamentally different environmental challenge. So again, demand's going up, and the real one of these challenges is it's not quite clear to us yet exactly what the market structure is going to be to meet that demand. Next slide. So by last year, you remember the 2000 chart, we had these 3 challenges. Now we really see these 5 challenges because added into it have been climate change and energy. And I think one of the key challenges we see is that these aren't standalone. The reality is certainly the engineers here at NASA understand, there's interrelationships between noise and emissions, local air quality and climate, because there are trade-offs when you build these planes and operate these planes in terms of the different factors you're optimizing for. And so part of our challenge is the fact that we have to tackle all these environmental issues, and we have to tackle them in a way that makes provision for the fact that there are these interdependencies. So how are we trying to go forward on this? So next chart. Let me talk about NextGen and some of the strategies we have there. Next one. So our NextGen vision and environment, as it says here, is to provide environmental protection that allows sustained aviation growth. And I've listed a bunch of key initiatives in this chart, and certainly I'm going to go through them in the next few minutes. But I think it's important to note this. You can see the cover of this report to Congress that was done several years ago. In fact, in the same reauthorization that actually asked FAA to help set up the Next Generation Air Transportation System plan, it also asked FAA and NASA to come together and look at a set of environmental technologies that might be needed. And we actually went back to Congress and said, we think you're asking the wrong question. I mean, because you could have forecasts of all kinds of technology and operational improvements we might need, but unless we understand what the goals are, we don't know what we actually need to do. And so they said, fine, ask what we actually, what are the objectives? And so we also took the unusual step of, we had created a Center of Excellence partner about that time. And so we asked partner to put together a study, a cross-section of organizations. And so we actually had 38 different organizations. So other government agencies, industry, but community groups and environmental representatives to try to come together and see if we could have a coherent vision of where we wanted the system to go in the United States. So next slide. And the good news, I think to some people's surprise, is we actually came up with a vision. We all agreed that in order to move forward in a responsible fashion, we wanted to reduce the significant impacts from noise and air quality, even as we allow growth. We wanted to reduce the uncertainties related to climate change and health impacts of emissions. We wanted to change the nature of communities and airport relationships, and we also wanted to ensure that the U.S. was a leader in developing these solutions. The second one, limit or reduce, was not part of the original charter, but we've added that based on the U.S. Agreeing to with other countries at ICAO this goal on climate. So this is our vision of where we're trying to go, and so let me just briefly walk you through of some of the strategies. Next slide. So first, better scientific understanding. Again, this seems pretty basic, and certainly for this audience, I know you understand this, but there's an awful lot of shoot first and then figure out what you're aiming at too often in the policy arena. And so we've really made a commitment to try to get right the science and to try to use good scientific understanding to develop the metrics. And this is both on individual issues as well as I mentioned earlier, the interdependencies. What are the trades in these different issues? And certainly NASA has been playing a very significant role to help us here, and certainly I think they have a larger role ahead. Again, just to give you a sense, next slide, of I'll only show one of these eye test charts for this, but this is just to give you an example of the roadmap we've laid out on emissions. And you can see that all the yellow boxes are basically the number of studies that are going on to try to frame out both emissions and speciation, chemistry, climate metrics, air quality metrics. And again, this is being done both with FAA resources, certainly with NASA resources. We've tried to leverage our partner center of excellence with industry contribution. And again, I think what's really important here is there are a number of critical initiatives here that are not what I would call the 20-year science, but actually geared toward how do we use the information or slightly improved information to develop metrics for a regulator that actually has to develop things for the system. So again, I know my chief scientist, Dr. Lourdes Maurice, is here in the audience. I know that I drive her nuts sometimes because I'm a regulator. I'm a regulator hat, and the issue is it's not the research project of 10 years from now. It's what can we start understanding now to actually build technology or build metrics to actually change the system now. And again, that's part of why this framework was laid out. But again, this is just one of many frameworks we have to try to tackle these different issues. Next slide. Now, hit it one more. Yeah, great. So, and part of what we've been doing over the last few years is not just the understanding, but also trying to build a set of tools to be able to look at trade-offs. This is basically an outline of 3 different models that we have been working on to try to have a capability. EDS is our environmental design space. So this is really at the aircraft level, to have this capability to be able to look at the aircraft design and say, what are the trades in noise, NOx, other emissions, fuel burn, to really understand, at least within one standard deviation, if you would, what are the kinds of trades that we need to understand in terms of next generation aircraft. And then in AEDT, this is our operational model. So as you take these new kinds of aircraft and what their trades are, as you plug them into actually as you operate the air traffic system, what kind of trades are we making in terms of how we operate the system in terms of noise and fuel burn? And then finally, the Aviation Portfolio Management Tool, the APMT, you have these 2 blocks, one on what are the costs, both to producers and consumers, but also what are the benefits. And what's important here, and where all these arrows go to, is we're trying to drive toward a cost-benefit analysis of aviation environment and be able to look at cost-benefit on an interdependency basis. So this all sounds maybe like gobbledygook. Why is it important? Let me show you the next slide. All right, so you have these 2 test cases where we try to use these new tools to show the difference it makes. So in the top left chart, what we did was take a policy analysis scenario, which is pretty typical for ICAO, which is to look at a new NOx stringency standard, which is basically how much increase in stringency will we ask new engines to be certified to, and in what year. And you can see the 4 different policy cases were looked at. Now, traditionally, the way ICAO would look at this would be a cost-effectiveness analysis. And if you're doing a cost-effectiveness analysis, what you would do is get rid of all those bars except where it says LAQ, local air quality. Because in essence, you're saying for a certain number, for a certain cost, what is the improvement? And so you can see in a cost-effectiveness analysis, the yellow bar is the most cost-effective, and that's what we normally would choose. But if you stopped and said, well, wait a second, this clearly has trade-offs and impacts and other effects, for instance, in noise, for instance, in climate, because of fuel burn penalties, and certainly costs to consumers and producers. From a cost-benefit standpoint, what might be the best choice? And you can see clearly what we normally would have chosen in ICAO as the cost-effectiveness is actually the least cost-beneficial. So again, already by using this kind of cost-beneficial model, we actually have improved knowledge and understanding about what our choices are. But I think as important, what you can see on the right-hand side is as we started trying to exercise these tools, we started saying, well, perhaps stringency isn't, the best solution forward if we're trying to really deal with air quality issues. So we did this analysis basically looking at what happens if we developed an ultra-low sulfur fuel that was able to drop into today's fleet. And suddenly, you have some really interesting results because, one, there is no noise cost because, again, you're not changing the noise or the design of the engine. There's a huge, order of magnitude difference of improvement in air quality. Not surprising because instead of trying to put a new engine across a fleet in 12 to 15 years, you have an immediate drop-in that you have immediate benefits. And you can see that, there are, again, not large producer issues because, again, you're not going to have to change engines. There is some cost. No one says there's a free lunch. But, again, you end up in a much better position in terms of the overall cost benefits by using this fuel. So again, we're hoping that the tools we're developing are going to give us a more robust ability to really look at a number of different issues to tackle things cost beneficially. Next slide. Another issue that we're really trying to push hard on is how we change how we operate the system. Again, we think this is essential, especially for near-term gains. You can see in some of the bullets here, in terms of reduced vertical separation, something the U.S. put in 2005, which is a fancy way of saying we created more efficient lanes by closing the gap between planes from 2,000 feet to 1,000 feet at certain altitudes where planes are designed to operate most efficiently. You can see here that saves about 300 million gallons of fuel each year. It's about 1.8 to 2% of the fuel burn in the United States system. So again, not insignificant. And we're continuing to push the envelope in a number of different areas in terms of continuous ascent arrivals, required navigation. In fact, if you can hit the slide a couple times. One more. So you can see the before and after of the noise footprint at Louisville Airport, where we initially ran some of our continuous ascent approach trials. And you can see the significant improvement in terms of the flight paths and the shrinkage of noise exposure coming in. And the nice thing about something like continuous ascent arrival is that you actually have the ability not just to reduce noise, not just to reduce fuel burn, but actually reduce NOx in that last leg. So you actually have a win-win-win situation, which is a little unusual. Next slide. And again, probably I'm speaking to the choir here, but you folks know this much more than I do about the role technology has played in the past. As we say here, about 90% of the footprint we've gotten in improvement in aviation has come from the technology improvements. And we certainly think that this is crucial going forward. We think while clearly air traffic procedures and such can give us some near-term gains, they are not going to be the game changer. They are not going to fundamentally change the need for new technology in the aircraft, in the airframe, in the engines. This is really going to be absolutely essential if we are going to meet the environmental requirements of next gen. Next slide. I think one of the new game changers, and again this is a technology outgrowth, is alternative fuels. Clearly with where the price of oil is today, it has made it a lot easier to undertake the work we've done. But as we've laid out in this slide, the FAA with industry, airports, airlines, and manufacturers a couple years ago started the Commercial Aviation Alternative Fuel Initiative. And we have laid out a number of different pathways there, looking at all the life cycle environmental costs, different R&D issues, importantly, the commercialization of this, the business case for it, and also, as important from an FAA standpoint, the qualification and safety of it. So we have 4 different tracks going on this right now, and I have to say there's been an amazing amount, pardon the pun, energy that's come around this initiative because we had to, I think, upsize the room 3 times when we had our meeting in November. There was over 130 participants, and I think excitingly for me, it's not just the industry, or we'd say the traditional industry. We actually had biotech companies here, we had refiners here, we had the oil companies. I mean, this is really a broad-based interest, and I've really been encouraged by how quickly this has moved. And certainly, you've seen the announcements, the demonstration flights done by Boeing and Virgin and the biofuel. Continental is going to do something this spring. So again, we're really excited about seeing this move forward, and we really do think this potentially offers the ability to be a game changer. Next slide. So going through all this, if I leave you one slide from my presentation today, this is it. And that is FAA and NASA, to my mind, is the essential partnership if we're going to be able to tackle the next gen environmental challenges. As I try to lay out here, what NASA does flows into what FAA can do. Whether you're talking in terms of technology research, of the foundational research you're doing, that will flow into the technology maturation process that we have envisioned. When you're looking at alternative fuel research, when you're looking at the operational research in air traffic, the science, and certainly in the analytical models that we're developing, where we're able to go in FAA, certainly in my office as a regulator, has been dependent upon the past intellectual accomplishments and investment of NASA, and certainly we require that same kind of partnership going forward. So from my standpoint, this is the absolutely essential partnership if we're going to be successful. Next slide. So let me just briefly talk about a couple of FAA proposals. Next slide. The FAA in its reauthorization before Congress put together a number of environmental proposals which we thought would help NextGen. I've mentioned three here, the Research Consortium for Lower Energy Emissions and Noise Technology, or the CLEAN Partnership, the Airport Cooperative Research Program, and some environmental mitigation demonstration pilot programs. So I'm going to talk more about CLEAN, but let me just touch on ACRP and the demo programs. So today, FAA has about $10 million from airport grant money that is allowed to be used for a variety of kind of research projects at the airport level. So what we proposed is, given the number of proposals that had come into the ACRP, that we set aside $5 million additional dollars targeting toward environmental research at the airport level. So the good news is, Congress thought that was a good idea, and that was blended in. The Environmental Demonstration Program, this was where the FAA proposed that we would fund up to 6 projects using, again, airport grant money, up to $2.5 million to be matched by other folks that would join us in those demonstration projects to be able to accelerate, through technology demonstrations, various kinds of environmental improvements. And again, I think by and large, the really good news, if there's good news in FAA reauthorization, is that all the environmental provisions that we put forward were taken up in both the House and the Senate bills, and were widely supported both by the Democrats and the Republicans. So we're probably the one part of the FAA reauthorization bill that got wide support. So that's the good news. The bad news is it doesn't appear at this point that FAA reauthorization is going very fast because there were a lot of other issues where there wasn't that agreement. So hopefully at some point in the future, the FAA reauthorization bill will come forward and we'll have these provisions. But again, that's way above my pay grade. But let me just talk a little bit about CLEAN. If you go to the next slide. Again, where we're trying to go in CLEAN, as it says in the second bullet, is really establish this world-class consortium that's going to be focused on maturation. So the idea here is to be able to take the lower level TRL concepts and developments within NASA and bridge the gap that has occurred where industry hasn't taken it up. So what we want to be able to find a way is how to bridge that gap to get those concepts up and those new technologies up to a 5 or 6 level so that industry will take it up, and we will then accelerate, again, the path of technology into next gen. Now, in our assessment, this is really crucial because, frankly, 2025 sounds like a long time away for most of the public. You all know, and I know, that is not a long way away, especially when you're talking technology. When you talk about it takes 12 to 15 years to get the average technology through a fleet to make a difference, then we really don't have a whole lot of time. So this is why this is so essential and why we're working so hard to try to get something like this set up. Now, I think the good news in this proposal is that even though FAA reauthorization is stalled, this proposal is actually in the President's FY09 budget. So FAA is moving ahead in hopes that the President's budget will get passed, and we're moving ahead with NASA. I mean, working very closely with NASA to develop the infrastructure to set up CLEAN. There'll be a bidders conference in mid-May. And again, I think the really good news here is we've been working very closely with NASA. I give Dr. Juan Alonso a lot of credit to really join with us in partnership, and I do think this is really going to be a significant contribution to the way forward on NextGen. Next slide. So can we succeed? Always an important question. So let me go through just a couple charts here. Next one. We had, in looking at NextGen, one of the issues was what were going to be the kind of environmental impacts on the system. And so we worked with the analysis group at the Jpdo to try to do an assessment of, with fleet change and growth in operations, what does that mean for emissions and noise? And so as you can see here, what we tried to do was a calculation where we looked at the top airports, 34 of the 35 top airports, and 100 for noise. And then we did, for emissions, there had been another study done on emissions, and we used about 100 airports. The only airports we didn't use were not in the CONUS. Regrettably, we did think of maybe looking at Hawaii, firsthand observation, but somehow that was vetoed. But anyway, but what we wanted to look at was, given the level of operations, and we wanted to say, given the forecast of operational increases, given the kind of changes in the system, again, you can see here we were looking at trying to build in some of the CDA improvements, trying to build in some of the RNAV improvements and the improved trajectories from NextGen, but also constraining it because we didn't want to get as it says here, the delays any worse than they were in 2001. So we were trying to get a sense, looking at those kinds of operational levels, what would be the impact on noise and emissions. So if you go to the next chart. And again, we were interested in the technology change piece. What happens being able to use different kinds of technology? So we did a baseline fleet that MITRE had developed in terms of the logical or what their forecast was of the fleet change. And then we tried to look at a couple different technology changes of if you had the best aircraft technology in a particular C class, if you only use that one. And then we also wanted to look at building in a slightly newer technology that, again, and this was where NASA was very helpful because, again, NASA leads the technology panel of the environmental work group. So again, we were trying to figure out what was the technology path and actually could it help. So next chart. So you can see some of the results we had. Again, this was for noise, and you can see based on the level of operations, you can see with a non-next-gen, clearly noise is going up, and actually the bad news is with next-gen operations, noise goes up even more. And so then, how does technology help us? Well, I think the really good news here is you can see with next-gen level of operations and best-in-class, we can clearly get near that 1% goal. And I think the really good news is with the new technology added in, we can actually meet that 4% goal. So I think the good news from this was, again, and this is it was an exercise, not in stone, but I think what the really good news is, technology from the noise, or the noise area, clearly offers us a pathway forward. Next chart. So here you see the same exercise in emissions, and you can see that, again, this is more challenging. Clearly, with next-gen level of operations and the improvements and best-in-class in aircraft, we don't make it. And you can see next-gen with new technology, we do make it, but my proviso here is, remember, the goal we had set right now was a 1% efficiency improvement. We didn't say something like carbon neutral growth. We didn't say that we'd have efficiency that would offset all the growth, and we certainly didn't set a goal at this point which said absolute decline in emissions. So you can see the challenge on emissions is going to be much more striking and a much larger pole in the tent. But again, this was important just to give us a sense of where technology might be able to get us. Next slide. So again, you can see this is just to summarize things. And again, I think the important thing is, don't take this as gospel. This was one exercise. I think the good news is we're actually trying to refine this analysis over the next year with the Jpdo folks using our new improved models. So I do think it will get us a better sense of where operational improvements can take us, as well as I think where technology will need to take us if we're going to be successful. Next slide. All right, one more. So in closing, I think, as I've tried to outline for you this morning, despite past progress, environmental constraints to growth are real. And in fact, I would argue that the largest constraint to the next-gen plan is environment. It's likely that a lot of the capabilities in next-gen will never come to fruition and never to be able to be fully used unless we solve this environmental issue. I think the challenge is that the environmental constraints are going to be a lot more complex than they were in the past. If you think back 30 years ago, it was mostly all about noise. We're not in that world anymore. We've got to deal with noise, air quality, climate, energy, and water. So we're in a much more complex world, and certainly, as I've tried to argue, that a lot of these are interdependent. NextGen is not going to succeed without technology and operational improvements of a high order. Again, even with that early analysis, it seems very evident to us we are going to need a large aeronautics technology input into next gen if we're going to have any chance of actually meeting the goals that Congress has assigned us in next gen. And I think, again, the initial assessment is good. It gave me some encouragement. And as I've tried to say, partnership with NASA is absolutely essential. NextGen was all about setting up a multi-tiered, multi-agency approach to try to tackle meeting the demand for the future system. And certainly from my standpoint, a number of agencies, it's nice that they're part of NextGen, but frankly, from my standpoint, NASA is my essential. We clearly don't have the kind of background expertise, knowledge base that you all have in technology and some of the earlier levels of operations. We absolutely need those if we're going to be successful. And I think what's important to remember, I think in this whole discussion on environment is, people will say, well, there's other things more important right now. Maybe it's certainly safety has made the headlines right now. Certainly security tends to make the headlines every once in a while. It seems to me the issue here for us is how do you lay out a framework and a long-term strategy? And I like to use the example of ICAO and the vision they had once upon a time. It always struck me as amazing that the Chicago Convention, which really set up the international system in aviation, was chartered in 1944. And here we were, think about that. You had a group of 52 nations come together in the middle, still prosecuting a world war, and yet having sufficient vision to say, we know what's going to come in the future. The commercial aviation is going to change the world. We need to lay out the foundations for that. And so I would argue the same thing in terms of environment. We've seen the potential constraints that environment is going to produce on the system. So we need to put the framework in place now. We need to put the strategy in place now. And certainly from my standpoint, we need to have the partnership between FAA and NASA to tackle it now in order to be successful in the future. So thanks very much, and I'll be glad to take some questions.
I'm Beth Dickey with NASA Headquarters Public Affairs, and I'll be moderating the question and answer session this noon hour. Please wait for the microphone and identify yourself before asking your question. Does anyone here at Headquarters have a question? Anyone? All right, I do believe we have one from NASA's Glenn Research Center in Cleveland. Go ahead with your question.
Hi, Carl. Yeah, Dennis Huff. Great talk as usual. Do you see a scenario, certainly with the recent demand on fuel and the cost, and do you see a scenario where perhaps noise and emissions becomes neutral and we really go all out on working on fuel efficiency?
Thanks for the question. I don't think so. I mean, I wish it'd be nice if we could only focus on one challenge. But I think the tendency is that while we may, from a strategic standpoint, think we need to address fuel, the reality is if you look at capacity expansion projects, the things that tend to hinder that are noise and air quality issues. So I don't think we're going to have the luxury of only being able to focus on one issue. I think part of why we've been building the tools we have and actually taking the approach we have is this clear recognition that as much as we'd like to have the beauty, if you would, of solving one problem at a time, we actually have to take it in a basket and solve it as a portfolio.
Are there any other questions here at Headquarters? Back here.
Carl, I'd like to do a takeoff on Dennis's question. It does seem recently that the Europeans are much more focused on emissions than noise. They seem to have done a flip there. So do you ever see a situation where U.S. operators could be penalized in their ability to operate on an international scale due to choices that we've made here in the States as far as which technologies to advance?
So let me try to broaden that question, but there is a large issue in debate internationally right now on what to do about greenhouse gas emissions. And certainly Europe has proposed a solution set, which is to put international aviation in their emissions trading system. And that has elicited pretty broad opposition from most of the world, not being against, not the issue of emissions trading, because again, ICAO passed guidance there, but really Europe has decided to unilaterally apply it without the consent of other governments. So I think that has produced significant conflict to date. It continues to be a friction point. Certainly if you follow the newspapers, you have various concerns expressed in Europe about the legality of it. Certainly from our standpoint, we have legal issues. My administrator, or my assistant administrator, was testifying last week before Congressman Markey's committee on this. So there's an awful lot of issues going on about that. So I think there's the potential that our operators will face charges and permitting fees. In fact, a couple of governments in Europe have actually proposed additional kinds of taxes in addition to emissions trading. So there's a whole movement in that part of the world toward penalizing aviation. And I think part of what we're trying to do is, how do you find a way forward that isn't punitive, but really performance-based? I mean, part of what we've tried to outline to our European colleagues and others is there really is an ability by using technology and operational change to get where we think we need to.
Carl Juan, thanks for the talk. Very interesting. I was going to ask you, when you're considering multiple things, not just fuel burn, noise emissions, but altogether, it's clear that the airlines have a strong incentive for global climate issues by reducing fuel burn. But how do you think the goals of the next gen will be attained in some of the other areas where perhaps the airlines don't have as much of an incentive to sort of move aggressively forward on?
Oh, I thought that was your job. No, seriously, I think part of the issue, and we've talked about this in my office, but one of the successes in the past was the technology that was developed that actually reduced noise was adopted because of reduced fuel burn. And I think part of certainly my hope in the CLEAN consortium, as well as the work that NASA is doing, is that there has to be this twin focus, not just on how do I reduce the environmental impact, but also how do I create a technology that actually is cost beneficial to adopt. If I can, paraphrase Tom Friedman, columnist for the New York Times, he wrote about getting environmental technology as a centerpiece of the 21st century American economy, and he argued the way to do that was you have to marry Mother Nature and father greed, and so I think that's that issue of trying to bring together those environmental improvements, but having that element that they are more cost effective. So I'm looking forward to seeing what NASA can offer.
Back.
Yeah, I have a question about the, yes, this is Cinda Lee. I'm with the Science Mission Directorate. I was in a workshop not too long ago, and one of the colleagues identified a issue. I don't know if you share the same observation, that there's a challenge that all the many of the independent software vendors who's supplying the analytical models and tools to the airline industry, those vendors are disappearing. I don't know if you share the same kind of observation, and if there's a program to develop such a analytical models and tools.
I have to say that it's a good question. I'm not aware of it, or at least that part of the industry, of whether there is this problem. I mean, certainly, as we have moved forward to try to develop our own set of integrated tools, one of the challenges has been to, one, make sure there's this balance of vendors that actually have capabilities and can bid on it, and two, that we don't become over-reliant on one source or one software package. and become an obstacle to actually getting the entire program done. So, but I'm not aware of this issue in the airlines, but certainly I'd be willing to talk to the airlines to see if this is an issue.
Any more questions here at headquarters? All right, I've got one or two that have been submitted, so I'll just stick one of those in now. In your opinion, what are the relative and/or complementary roles of technology and operations in reducing the environmental impact of the aviation sector? You touched on this a little bit, talking about the partnership between NASA and the FAA. Can you go into more specifics?
So I think, again, I think there are elements that both NASA and FAA bring to this whole issue of operations and technology in trying to tackle environment. Certainly, as I was showing in my chart, you all have this foundational role that we clearly lack the capability of, and we're trying to develop this role of trying to transition technology to a more mature state. But even in the operations side, I know how much the part of NASA that deals in my air traffic organization that builds the tools and these new capabilities. So I see this as clearly linked. I think more fundamentally, the issue is, if you would, my bottom line is what can it give you, and in what time frame. From an operations standpoint, what I see is the ability to deliver real improvements in environmental performance in the system in the next 5 years. Because again, this is taking today's, upgrading FMS capabilities, upgrading, using RNAV, using C8, actually getting into the system. So those are the kinds of things that can really make a benefit. But the reality is, and we've looked at this, is those benefits tend to be relatively limited over time. They are not the kind of game-changing things. And certainly, as you increase operations with some of the efficiencies, some of those may be overtaken. So the real issue, I think, is how do we get the technology of the engine, the airframe, and I think now alternative fuels into the system to actually produce that longer-term reduction. And I think, again, that's where NASA is actually absolutely essential. And you didn't ask this on the sort of the operation and technology, but one other dimension I just want to mention is that, again, I come back to we have to design operations and technology to solve the key issues. So this is why when we started our program, it's founded on good science and good metrics. And I do think that's absolutely another essential role for NASA, because clearly in the past, NASA in the climate science area of aeronautics has been very important in terms of producing the understanding we need. And we recently, FAA with NASA and NOAA launched the Aviation Climate Change Research Initiative. And certainly, and that's all geared toward trying to produce the information and metrics we need to make good decisions. And so I think NASA's role there is going to be absolutely critical.
Any other questions here at headquarters? Carl, you mentioned your economics training, and I'm interested in looking at this from an outside point of view, the money angle. In developing technologies to reduce fuel emissions and to reduce fuel burn, where does the break-even point come for the airlines and the aircraft makers? Have you thought a lot about that?
We have done some work on this, but this is part of why we're trying to develop these new sets of models. I mean, traditionally in regulatory analysis, at least in developing standards for environment, it's been done through the International Civil Aviation Organization. And traditionally what they've done is, as I was showing you on one of the charts, is cost effectiveness analysis. So they really haven't thought through, if you would, the cost benefits or the linkages in the choices that are being made. So part of what we're trying to do is develop that capability on a global basis and then also look at it at a national basis. So I'm hopeful that as we develop those tools, we're going to be in a better position to at least provide public information as well as help the airlines think this through. And I think importantly, another part of why we're trying to do this on an interdependent basis is from a public policy standpoint, we think it's better that you lay out all the issues rather than, if you would, kind of slice and dice people. Say, first we want you to solve noise and you have this big air quality issues you've now contributed to, and then we want you to solve air quality. We think it's a much better public policy process to really try to lay out, here are all the impacts, here are the solution sets, and here's how we can get there.
And the public policy aspect that you mentioned is another one that I'm curious about. Is there a message that you can send to the public that's more worried right now about lost luggage and the price of airfares to help them understand that these sorts of innovations are necessary and will help them in the long run?
Well, I think most Americans, they have come to view aviation as their mass transit. I mean, it really is interesting when you look at Europe versus the U.S. And again, Europe with much less land mass, much more urbanized, has built a train system at least as an alternative, although even in Europe, they have to subsidize it at about 50 billion euros a year. So that presents a challenge. But I think in the United States, aviation is our mass transit. And I think the issue, of course, is, I know you all have had this experience, I've had this experience, sometimes you feel like you've been put on a mass transit bus. But be that as it may, it has transformed, how we get around. And I think the issue for aviation, and I think in trying to plan, is you have to translate this into the ability of Americans to continue to fly and have a lifestyle based on that. Because I think whether it's the environment, which I'm clearly concerned about and its impacts, or whether you're talking capacity, and that is, do you end up spending 4 hours in a line to get on a 2-hour journey? All those are built around, do you have access to the kind of air travel you want? And I think the upside for NextGen is that you actually have a number of agencies trying to plan, in essence, curb to curb, from when the time you drop off, you get dropped off to travel to the time you walk out of the airport. So hopefully we'll be at least within one standard deviation of getting the plans right and then providing that ability for the American public to continue to travel.
Do we have any more questions from our centers? Any more questions here at headquarters? Back here.
Hi, Brandon Bush, University of Maryland. The rotorcraft industry it's associated with the civil aviation industry, but it's not exactly the same. Are there any initiatives in the NextGen program specifically geared towards the problems relating to rotorcraft?
Not that I'm aware of. I mean, there is there is work going on with an FAA, and I know NASA on rotorcraft, and certainly I think Jpdo has a pretty large program. But the real focus on NextGen to date has been either the large commercial aircraft or some of the, if you would, the very small jets, or potentially supersonic.
Okay, thank you.
Any other questions here at headquarters? Seeing none, then I'll wrap up with one last one that was submitted to us. Has the Jpdo adopted FAA's goals for environmental impact for the NextGen plan, and will there be compromises? If so, what compromises do you envision?
Thus far, what Jpdo has adopted is, and you can look at the environmental work group plan in the integrated work plan of the Jpdo, is as for planning is the FAA goals in terms of 1% reduction in emissions and the 4% target in noise. But we're actually going through the process right now in the environmental work group. We have a policy standing committee which is working through the long-term goals for NextGen, for noise and air quality and climate, and what those should be, as well as the metrics. Now, my guess is you will have a certain set of answers that come out of the environmental work group that will then be put into a larger public process, and I wouldn't be surprised that this is going to produce a rather robust debate. If I can give an example from my own family, when we had been living in London, and when we came back from London, we went to visit my sister in Charlotte, and my niece remarked several times during the visit of how much my sister and I looked alike. And after several times of remarking that, then I asked my younger son, so Will, do you think your aunt and me look alike? And he said, well, Dad, no, I don't. You don't look anything alike because my aunt's pretty and you're old and ugly. So what's interesting to me, again, is that, two people, my niece and my son, faced with the same information, my ugly face, came to very different conclusions of that resemblance. And so I think certainly as we have the discussion, there will probably be a lot of different views of how to balance environment, capacity, in the whole context of NextGen. But again, I think that's the kind of debate we want to have. And I think the good point of NextGen is that we've done this in a very structured, public, and transparent process, which hopefully are going to put us in a much better position of where we need to go forward and how we need to tackle those challenges.
All right, Carl Burleson, thank you for spending time with us this afternoon. We appreciate it, and it's been a very good talk. For more information on this, you can go to the NASA website, aeronautics.nasa.gov. And with that, we'll call it a briefing. Thank you.
Thank you very much.